Hey everyone, and welcome. Today we're going to dive into something that's basically magic, the stuff that brings order to all our digital chaos. We're talking about sorting algorithms.
I mean, really think about it. You've got, 1,000 photos on your phone, you hit sort by date, and bam, it's done in a flash. It feels like it shouldn't be possible, right? Well, it's not magic. It's just some seriously clever logic. And today, we're going to pull back that curtain and see exactly how it works.
So what are we really talking about? At its core, sorting is super simple. It's just arranging stuff, taking a total mess and putting it in some kind of order. You know, smallest to largest or A to Z. It sounds basic, but it's one of the absolute cornerstones of computer science. All right, so let's start with what I like to call the simple sorters. These are the ones that are so intuitive, you could almost figure them out on your own. They're the real foundation for everything else we'll talk about. Okay, first up is a classic, bubble sort. And honestly, the name tells you pretty much everything you need to know. Just picture bubbles in a drink rising to the surface. It's the same idea. The biggest items slowly bubble their way up to the end of the list. So how does it actually work? Well, it's pretty simple. The algorithm just looks at two items right next to each other. Is the one on the left bigger? Yep. Okay, swap them. Then it just shuffles over one spot and does the exact same thing again. It just keeps making these passes through the whole list. And every time it does, another one of the biggest items finds its final home at the end. It's straightforward for sure, but man, that's a lot of tiny little swaps.
All right, let's switch gears a bit. Next up is selection sort. This one has a totally different personality. Instead of all those little back and forth swaps, this algorithm is, it's a hunter. It's way more decisive. Here's its game plan. It scans the entire messy part of the list, looking for the absolute smallest thing it can find. Once it's locked on, it does just one big swap to move that item to the very front. Boom, done. Then it's like, okay, that one's sorted, and it does the whole thing over again for the rest of the list. It's very methodical, one pass, one perfect placement. And to round out our simple sorters, we have insertion sort. Now this one is probably the one you've actually done in real life without even knowing it. Seriously, if you've ever sorted a hand of playing cards, you will already get the basic idea.
So imagine you're holding your cards. You pick one from the unsorted pile, then you look at the cards you've already sorted in your hand and find the exact right spot for the new one. You just slide it in, shifting the others over to make space. That's it. It builds up the sorted list one item, one card at a time.
Okay, so what's the big takeaway from these first three? Well, the main trade-off is pretty clear. They're super easy to understand, but they're not very fast, especially for big lists. The number of steps they have to take just explodes. The one little exception here is insertion sort. It can actually be pretty zippy if the list you give it is already almost sorted. Good to know.
So those simple sorters are great, but for the big leagues, we need something better. This is where a really powerful idea in computer science comes in, called divide and conquer. The whole strategy is don't try to solve the giant problem all at once. Instead, just break it down into tiny, easy-to-solve pieces.
And the poster child for this approach is merge sort. Seriously, its strategy is just brilliant. It's not about wrestling with a huge list. It's about tearing that list apart until sorting becomes a total non-issue, and then cleverly putting all the pieces back together. Okay, so check this out. You take your list and you split it in half. Then you take those halves and split them in half. You just keep splitting and splitting and splitting until all you have left is a bunch of lists with just one item in each. And here's the cool part. A list with one item is already sorted, right? So now the real magic begins. You start merging those little lists back together, two at a time, making sure they're in the right order as you merge. You just keep merging these now sorted chunks until, poof, you have one big perfectly sorted list. All right, and now for the one that really lives up to its name, quick sort. This is a real fan favorite, the one you'll find used all over the place because, it's just so fast. It's also a divide and conquer algorithm, but it goes about it in a totally different and pretty clever way. So Quicksort's whole game plan revolves around this one idea, the pivot. It just picks any item from the list, doesn't really matter which one, and calls it the pivot. Then, in one fast move, it rearranges the entire list. Everything smaller than the pivot gets thrown to the left, and everything bigger gets thrown to the right. So now the pivot in is in its final correct spot, and you're left with two smaller, messy lists. So what do? You just do the exact same thing again on those smaller lists. Pick a pivot, partition, and repeat until there's nothing left to sort.
Okay, so we've looked at 5 completely different ways to get this done, from the super simple to the pretty sophisticated. Which brings us to the ultimate question, right? Which one is the best?
When you lay it all out like this, you can see a pretty clear story. Bubble and selection sort, they're fantastic for learning, but you wouldn't want to use them for anything serious. Insertion sort has its own little niche. It's great for small lists or lists that are nearly sorted anyway. But when you need real power, when you've got a massive jumbled list, that's where merge sort and quick sort come in. They might be a bit harder to wrap your head around, but that complexity pays off big time in raw speed.
And this is maybe the most important thing to remember. There is no single best algorithm. It's just not a thing. The right tool always depends on the job. You have to ask yourself, how much data do I have? Is it kind of sorted already? Things like that are what will tell you which tool to pull out of the toolbox. Now, I know what some of you might be thinking. My programming language has a sort button. Why do I care how it works? And look, that's a totally fair question. But the value here isn't necessarily about writing your own sort from scratch.
It's about understanding the story. It's about being able to explain these different strategies. You've got the patient, step-by-step approach of bubble sort, the decisive hunt and swap of selection sort, and the clever divide and conquer of the faster ones. Knowing these different ways of thinking makes you a way better problem solver in general, because you start to see the trade-offs in every approach.
So I'll leave you with this. The next time you sort an email inbox, a music playlist, or those 1,000 photos on your phone, take a second and think about the hidden story that's unfolding. It's not magic. It's the beautiful, elegant logic of turning chaos into order one step at a time.